This ladder diagram is running right now. The green path shows which wires are live. By the end of this video, you will know how to read a ladder logic diagram on sight. Not draw one, read one. Trace the energized path, recognize the symbols, and tell at a glance what every rung is doing. Watch. Power leaves the left rail, passes two closed contacts, and lands on this coil. That coil is on. The rung below it stays dark. Its path is broken. Read the green, and you read the machine. First, get your bearings. A ladder diagram is two vertical rails with horizontal rungs strung between them. The left rail is power, the hot side, always live. Call it L1. The right rail is the return, the neutral side. Call it L2. Every rung bridges the two. You read a rung like a sentence, left to right. Conditions first, the result on the right. And you read the whole program like a page, top to bottom, one rung after another. A PLC does exactly the same thing endlessly. It scans rung 1, then rung 2, all the way down, then jumps back to the top. 30 times a second. Forever. So reading is simple. Left to right, top to bottom. Let's prove it. Quick pause. Everything on screen, you can open free in your browser at CircuitDiagramMaker.app. No install, no sign up. The link is in the description. Open it and trace along with me. Before you can trace, you need to recognize 4 shapes instantly. A normally open contact, 2 parallel lines with a gap between them. It asks a question. Is this input on? If yes, it closes and power passes. If not, it blocks. A normally closed contact, the same 2 lines with a slash across them. It is the opposite. It passes power all day until its signal turns on. Then it opens and stops the rung. An output coil, a pair of curved arcs at the far right. That is the result. When power reaches it, it energizes a motor, a lamp, a valve, and a block, a rectangle with a name inside, like a timer or a counter. It reads the same way, just with a delay or a count built in. Contacts on the left ask questions. The coil on the right acts. Now the one skill this whole video is about, tracing the energized path. Here is the famous start-stop rung, live on screen. Rest your eye on the left rail, because power always starts there. Then walk right, one element at a time. Do not skip ahead. First contact, start, is closed, so power passes. Keep walking. Next, stop, a normally closed contact. Nobody is pressing it, so is passing too. Keep walking. The power reaches the coil, and the coil is energized. The motor is on. That is the green path. Every wire it touches is live. Every wire it does not is dead. Now look at what holds it on. Below start there is a branch, a second contact wrapped around it. That is the seal-in. The coil closed it, and power now flows through the branch instead of the button. The rung is feeding itself. Trace the green, and you never have to guess. The live path tells you which coils are on, right now, without running anything in your head. Once you can trace it, you can read it as plain logic. Contacts side by side, in a row, are, and every one must pass. Contacts stacked in parallel branches are, or, any single path will do. And a normally closed contact is a not, true while its signal is off. So this rung reads, if start or the seal is closed and stop is not pressed, then run the motor. Say it out loud. If the sentence makes sense, so does the rung. Let us use that to predict the future. That is really what reading is for. Start with everything off. The motor coil is dark. Now someone presses start. Trace it. Power through start, through stop, onto the coil. The motor turns on, and the seal-in contact snaps, close behind it. Release start. Does the motor stop? Trace again. Start is open now, but the seal branch is closed, and power still reaches the coil. The motor stays on. You predicted a latch, and you were right. Now press stop. The normally closed contact opens, the whole rung goes dead, the coil drops, and the seal opens with it. Motor off and stays off. You just read a circuit and called every move before it happened. That is the entire skill. One more layer turns a drawing into a real machine. The addresses. Look under each symbol for a tag. Inputs start with I. Start might be I0.0. Stop is I0.1. Outputs start with Q. The motor coil is Q0.0. Those tags are not decoration. I0.0 is a real terminal on the PLC, wired to a real button in the panel. Q0.0 drives a real contactor. So when you read a rung, the address tells you which physical device each symbol is. Trace the logic, then read the address, and you have mapped the diagram onto the machine in front of you. Different brands spell it differently. Siemens writes I and Q. Allen Bradley writes I:0. Same idea every time. A few things trip people up on their first read. A coil is not a contact. A coil writes a signal. A contact reads one. The same name, the motor, say, can appear as a coil on one rung and a contact on another. That is normal, not a mistake. Watch the normally closed contacts too. They are live when nothing is happening, which feels backwards until you have traced a few. And if you want to go the other way, I have a companion video on drawing ladder logic from scratch. It teaches you to build these rungs yourself, not just read them. It is linked in the description and on screen now. Reading and drawing are two halves of the same skill. Let us read a real one in a free browser editor. This is CircuitDiagramMaker.app with the DOL motor starter template open. It is the wired-up cousin of the rung we just traced. A control supply at the top, a breaker, the stop button, the contactor coil, and the overload down to the return. Click any part, and it is a real component with a label and a value. That coil is K1. Now the part paper cannot do. Hit Simulate, run the DC analysis, and the live path lights up on the wires. 24 volts from the supply, with real current through the running lamp. That highlighted route is the energized path, exactly what we have been tracing by eye. The software just confirms your read. One honest note, this editor draws and simulates control circuits. To execute a ladder program scan by scan, input to output, our sister tool at plcsimulationsoftware.com runs the full PLC. Both links are below. So here's how to read any ladder diagram. Get your bearings. 2 rails, rungs read left to right, top to bottom. Recognize the shapes. Open asks on, closed asks off the coil acts. Trace the energized path from the left rail to the coil. Then read the rung as logic and or not, and read the address to find the real device. Do it yourself right now. Open the free editor at CircuitDiagramMaker.app, load a template, and trace the live path until it feels obvious. Subscribe for a new diagram explained every week. See you in the next one.